Okay, so Supra is very excited to announce that we are pushing forward a new initiative called the Move Prize. Blockchain ecosystems, they need a lot of developer tools. The Ethereum ecosystem has over 100 already, but a nascent growing ecosystem in the Move language world. There's many tools that we have to start to build in order to build a robust, efficient, developer-friendly environment. The objectives of the Move Prize are to elevate the baseline performance of key general algorithms at large, promote diversity and availability of low-level libraries, crypto libraries in Move language and its virtual machine, increase awareness of the revolutionary potential of the Move language. The way this program is going to be structured, the Move Prize starts with a concept submission. Participants need to submit the idea, then you actually have to have a response, and we're going to allow almost anything, but we'll have a team that gives active feedback, and there'll be a period of development. Maybe it's 6 months, maybe it's 1 year, maybe the Move Prize is given out once a year, maybe 2025 we release the prize and we do this every year over and over again. Moreover, the judging of who wins this will be made up of a consortium of folks in the ecosystem that are stakeholders. These are representatives from different blockchains, different VCs, different universities, different programmers, so on and so forth. You can learn more on movecon.xyz/moveprize. The potential reward that Supra is going to put forth is $250,000. We will be expanding this initiative to other ecosystems, and we're actively receiving feedback and contributions. This is a movement that we think that can really push the Move language forward. And we're really excited to be the first ones to initiate this program. Let's now jump into Supra and what we're doing. Super dApps are a new breed of decentralized applications. And what I mean by that is these applications can do things that applications on other blockchains cannot achieve. So let's start with the issue. Most decentralized apps or dApps need to run through multiple networks to do more interesting things. Perhaps the dApp is running on layer 1, but requires external networks for price feed information, oracles to communicate with the world, cross-chain communication protocols or bridges communicate to different layer 1s and layer 2s, automation, decentralized if this and that networks, on-chain randomness, as we discussed quite a bit today, is also a very interesting topic that's usually part of the oracle problem. These are typically distinct networks. So one application has to rely on now 4 or 5 different networks to do really interesting things. However, the problem here is that your application now is as secure, no longer of the layer 1 it is deployed upon, but it actually is only as secure as the weakest link of the service that you utilize. This problem gets exacerbated when we move into layer 2s and this notion of layer 3s, where this network also needs to be communicated to a data availability network, an execution layer, a settlement layer, and then also price feeds, cross-chain communication, automation, verifiable random functions, verifiable compute, privacy preserving technologies that are typically multiple different decentralized networks. And remember, your application is only as secure as the weakest link. And if you introduce additional networks that your application relies on, then you create a scenario where some small component can really cause large churn issues in this kind of modular stack. So once again, each additional layer results in higher costs for builders and users. Why is that? Because you now have to juggle multiple tokens across each of the services. Then you also have broken security guarantees and liquidity fragmentation. There's different pools of funds here and there. The security is the weakest module that you utilize. And it's also going to add latency. When you go from one network to another, despite the service, if it's an external network, there's going to be communication costs there and back. There's also going to be computation costs of creating an agreement from this network to this network, and then verification of the cryptography costs by doing this. So it does end up with a slower solution. It also makes the developer experience much more complex. You have to deal with different frameworks, different programming languages, multiple gas tokens. The developer has too many things to manage in this type of world. What we're doing at Supra is introducing a better way to build, and this is achieved through what we call full vertical integration. What is that? That is a single platform that has multi-VM support, that has advanced transactional logic through automation or decentralized if this then that. Believe it or not, that does not exist right now in blockchain on layer ones. Nor do typically bridges exist on blockchain layer ones. And we have our Hypernova protocol, which is a cryptographically secure cross-chain communication protocol. And of course, our award-winning Oracle DORA, decentralized Oracle agreement. So every single block that on Supra will have Oracle data. And since we use threshold cryptography, we also have on a block-to-block basis on-chain randomness, so native randomness as well. So let's discuss what is full vertical integration a little bit further though, and whether this is a trend or not. Now, we can look into a couple of examples. We have eigenlayer on Ethereum layer 1 that are utilizing restaking in order to add additional services on top of existing Ethereum nodes. That's economic security guarantees. Now, that doesn't promise that each of the protocols deployed with economic security has been mindful and thoughtful about safety and liveness guarantees. In fact, very conscientious protocol designers are very rare. So a lot of developers are going to say, hey, this is a full service that we want to roll out, but they don't know what they don't know. And perhaps some of those services are insecure, has liveness issues, so on and so forth. So that's a concern. Nonetheless, this is an instance of vertical integration upon Ethereum. In fact, about a year and a half ago in Berkeley, our team, myself, Dr. Pate, so on and so forth, on our team met with Dr. Strom of Eigenlayer. And the conversation was around the fact that we believe that these decentralized world computers are acting more like like the original computer that was very slow, the size of a room, barely doing anything. And that there's so much compute, so much bandwidth available that these nodes can be doing other things. Like the whole point should be, in order to drive down fees across the board for all these services, you want to just maximize available compute and bandwidth so you can actually have not only better performance, but also better economics. The other two examples I want to give, as we're discussing this panel earlier today, is this notion of like Aptos is rolling out their BRF. Supra has a native BRF. We're one of the leaders in the bare probable random function world. And Aptos is rolling out their very, very interesting approach. And moreover, you have Sui. Sui's rolling out their bridge. These services on that network are on the same nodes, on their layer 1 nodes. Now, Eigenlayer restaking, Aptos and Sui rolling out their various services, which are usually typically considered Oracle services, but they are vertically integrating services across the same set of nodes. These are generally more of like a afterthought. So you're realizing, oh, this is great. Supra has been designing a system that has been deliberately vertically integrated, designed this way. So we have been thinking about this for a long time, and we believe we have the best network architecture to achieve this, and the best protocols to achieve these various services. We have unique protocol for each and every service. Supra is powered by our Moonshot consensus algorithm, which has been formally verified by the IDE prover at Microsoft. In our test across 125 nodes, we hit 530,000 transactions per second throughput, and we have fast data availability guarantees on the order of 500 milliseconds. This can be considered early finality or missed finality. Moreover, we have also optimized in some protocols related to data dissemination, consensus, as well as parallel execution strategies. Now, Moonshot is a type of algorithm, Byzantine fault-tolerant algorithm. For this throughput and its performance, there's not many other protocols that have passed formal verification. And Supra's research has also been innovating DAG-based, directed acyclic graph-based consensus protocols, which, from my understanding, is actually the state of the art at the moment. I believe some folks at both Aptos and other organizations have reviewed the potential and theoretical potential of Sailfish. The Sailfish DAG is a novelty, and Supra is actually actively running tests across Moonshot versus DAG-based protocols. Moonshot is more of a traditional classical consensus algorithm. Now we want to know what is going to have wider scale usage. We think a network with more nodes has more potential to be more valuable. The replication factor is higher. So we'll talk about that soon as well. Supra also is pioneering this notion of multi-VM support through this tribes and clans architecture. This is the design once again. The entire tribe must run the Moonshot consensus protocol or a consensus protocol. And these clans themselves are randomized subcommittees of the entire network. And our realization is that we could randomly sample the network in a very particular manner and provide the security guarantees and performance guarantees for the system to run multiple services all at once. So a single clan, remember, this is a subset of all the nodes in the network. They're doing this Oracle service, decentralized Oracle rig. In our research and understanding, the profound thing is that we realize with high probability, even if we randomly sample a clan, we actually only need 51% agreement for this type of protocol. 51% guarantees through what's called the quorum intersection argument, at least one honest node is present. And the answer is correct. And this only works if the entire tribe has an ordering system called a blockchain powered by a consensus algorithm like Moonshot, right? Or Sailfish, we'll see. Now, what's really great is 51% is very little amount of nodes in an entire network that was randomly sampled, right? But we can guarantee strong safety guarantees. 51% is also less than 67%. So we actually can get away with getting our safety guarantees faster because we only have to sample 51% of the random sample set in the first place. These traditional Oracle protocols require 67% of all nodes in the entire tribe to come to some sort of agreement. Whereas our insight is the following: we can randomly sample the network as long as it's actually random. And in that random sample subset, 51% can be doing the execution and will guarantee the safety and liveness and performance at strong probabilities. Each of these various clans can be running various services. So one clan can be doing the Oracle agreement, another clan can be doing our verifiable random function service. Servicing many ecosystems, our Oracle price feeds are already delivering data to over 80 ecosystems right now. Layer 1s, Layer 2s, subnets, parachains, Layer 3s, and testnets. We're offering our VRF, verifiable random function, as one of the industry-leading solutions as well across many ecosystems already. Now, we also realized that our system needed brain and a spinal cord and nervous system, right? And we realized that we think that the MoveCon is by far the most performance, safest solution to handle such critical tasks of the network governance, so to speak. But we also realized that we can random sample and provide execution sharding across different virtual machines in the kind of subset of a clan, of which we need a state commitment that can be formed through only 51% of the nodes in the clan for execution. This is one key component in our macro design for parallel execution strategies. Another clan can be running Solana, EVM, Wazen, so on and so forth. So we keep the clan secure by a couple of techniques. One of them includes assigning different clans to do different services. What's really interesting about Oracle services, many Oracle services are what you can call stateless, meaning to run the Oracle protocol or the VRF, for example, you don't have to synchronize your previous state. You just run the protocol and you're ingesting new information or creating new information or output. So that randomly assignment of different clans and different services in our network can be done at a frequent manner because every single step does not require a specific state synchronization. That's not necessarily true for execution sharding across virtual machines. That does require some state synchronization. Nonetheless, what's really interesting is that there are many Oracle services that don't need to synchronize the data before they can switch their roles to do other services for the network. And also the nodes within the clan. Remember, clans are subset sample sets, subcommittees of the entire network. We also want to randomly sample the constitution and the constituents of each clan. So periodically at every epoch, we'll shuffle the nodes within a clan itself. So this brings us to this notion of super dApps. What is a super dApp? Super dApp is something that obviously has to be low latency, has to be secure. There should be shared security. There should be a simplified developer experience. It should be cheaper for builders, and therefore should also be cheaper for users. Remember, this modular world, when you're using many, many external components, at some point I can virtually guarantee that maybe most of those external networks are going to start to charge you services, fees, and tokens, and so on and so forth. It's expensive for builders. And then ultimately, if we have a unified solution where it's like one token do everything, it's cheaper for builders and consequently cheaper for users as well. So we think the vertical integration of these proven product market fit solutions such as price feed, function randomness, product communication, automation services, so on and so forth. There is demand for those services already. These are basic primitives across every layer one. They all want this thing, these capabilities in order to do more interesting applications. So imagine on Supra, any dApp from any virtual machine can deploy on layer one, our Supra layer one, and leverage two or more of our native services like price feeds, processing communication, randomness, and automation, so on and so forth, in different combinations therein. Well, we call those super dApps because there are new capabilities that this application can do that you literally cannot do on any other ecosystem without relying on multiple other separate, disparate networks for those services. Let's talk about the various use cases here. So native cross-chain communication. These are the capabilities that are built into Supra in our roadmap. Native cross-chain communication, aka Bridge. Native price feeds, aka Oracle price feeds. Access to real-world data, through connectivity between blockchains for blockchains as well as blockchains to Web2 world. Native automation is decentralized if this then that protocol. That, remember, most of you folks don't know this, but blockchains don't have that. In a world computer, you'd imagine it should have that ability to be decentralized if this then that execution. So this is required for typically oracles to achieve. On-chain randomness, we use Oracle services as well. We achieve this through on-chain threshold cryptography. Moonshot, Sailfish have high throughput, low latency capabilities. Multi-VM compatibility is achieved through execution sharding across the WAN. So we have a very unique network architecture that's very suitable to achieve this. Blockchain liquidity is enabled by bridges and automation and Oracle price feeds. So you can actually unify liquidity across different ecosystems to some degree. Native DeFi systems are natural outcome of this. So let's look at some potential examples of super dApps. Next gen perp dexes using automation, Oracle's cross-chain communication. Okay. So right now, perp dexes, decentralized exchanges, don't necessarily, for example, earn the revenue generated from the liquidation fee. If a position gets insolvent, someone has to bring it back to balance. Usually there's something like 1% of the cost as a reward for those that execute this. That doesn't necessarily go to the DEX itself right now. And this is also a reason why there's so much various games being played in blockchains today where they're trying to get the Oracle data in or background the Oracle so that you can collect the liquidation fee. That's basically causing some very strange behavior among node operators and these opportunity hunters. But suppose Supra has native price feeds on a block-to-block basis and also zero block delay execution. Now we can enable a new revenue stream for the PerpDex application in the first place. Maybe they collect 70% of the reward. Maybe the node operator split 20% and 2% goes to the decentralized pricing at Supra. My point though is the super dApps are going to be interesting in their capability, but also it should enable new business models in Web3. Ultra dynamic NFTs, imagine using the on-chain randomness for attribution, a selection. You can use oracles or real-world data or price feeds to say, change the mood of your NFT or whatnot. The design of it can change based off different states of the world. Constant communication, if you want to remove it, maybe your NFT should adjust its look or display based off what's happening on Ethereum or some other chain. Universal decentralized identity solutions where you can have a unified identity across ecosystems, interchain data marketplaces. Maybe there's different data sets that are trained in AI on different chains, and Super can be a middleware hub to negotiate and do access control across the ecosystems. Ultimately, what's interesting is Super does believe that the hub and spoke model exists, that is better designed, but we can also work with layer ones and layer threes technically. So we already have the float of services there. So instead of just a hub and spoke, you should almost imagine this more of a sphere. That's kind of the way that we imagine our integrations. Universal financial controllers are interesting. Imagine smart contracts can manage different smart contracts and liquidity on both public blockchains, so legacy financial systems, privacy preserving, decentralized consortium, so on and so forth, right? This information, we also, on a network-wide basis, we can vertically integrate DeFi protocols such as managing vaults across different ecosystems, automating routing of liquidity to rebalance vaults, so on and so forth. And imagine if this was kind of built in such a way that it's almost to some degree a public good, as the fees would be generated for the decentralized treasury, which is owned by the decentralized network over time. That's the whole point. And then at that stage, I do truly believe it becomes a true public good. So let's talk about some DeFi super dApps, universal money markets. You might need cross communication, automation, or centralized if this and that can be triggered based off of Oracle data, price feed, state, etc. Cross-chain insurance protocols. Maybe there's some sort of policy on one chain that you want to be enable it to be covered in another chain, so on and so forth. Cross-chain arbitrage solution. Perhaps you have limit orders to say, hey, listen, if the price of Bitcoin doesn't hit $85,000 by this date, then convert my stablecoin to Ether. You can do strategies like that, perhaps in a cross-chain environment. We're actually dealing with the native asset. You're dealing with real Bitcoin, real USDC, real Ether in this example. Interchain governance mechanisms. Many protocols are going multi-chain. It's a good thing we can be a hub and the headquarter for these applications where they can communicate, aggregate, and execute various governance decisions from a single place. So imagine if you had the governance across 3 or 5 chains, each of them have different users, or figuring out how to do that. What if there's one place where you just do it all and it executes the answer across all the other chains that the application has already been deployed upon? Cross-chain collateral, maybe you use your Ether to put it up to borrow some other asset on some other chain. Maybe you're picking up your Ether to borrow some token on Solana to do some sort of behavior or activity there. We need cross-chain communication. You're going to need oracles here as well. In automation could be interesting. Cross-chain asset management, perhaps some sophisticated strategies on how you want to manage native assets across different chains. Imagine if you had a policy on Supra that could execute in an automated fashion different types of strategies and like rebalancing or so on and so forth across many other chains in a cryptographically secure manner. That's what we think is really interesting about what Supra is bringing to the table. CBDC, Central Bank Digital Currency, we're not really big fans of this at all, but there will be stablecoins, and there'll be stablecoins in USDC, different currencies, there'll be on-chain FX, and the tokens are going to be issued across different infrastructures. We think we can also play a role here. We rolled out FX data with our price feeds and also our existing crypto feeds, equities, commodities, sports data is all in the works as well. So there's going to be, I think, a on-chain FX opportunity between stablecoins. Receivable tokenization. So maybe you're a business and you have supply chain inventory and you can tokenize that for faster liquidity to do other things. Tokenize deposit, maybe have some funds into a bank or whatever institution, and they want to tokenize those deposits and issue a stablecoin against that as part of the revenue model. Who knows, right? There's some interesting things here. We expect there's going to be many unique super dApps coming from builders who truly understand the power of Supra's vertically integrated infrastructure. But some of those folks are going to create things that we have never thought of. Super dApps, we believe, will redefine the blockchain experience for all builders and users across Web3. But new use cases will be enabled through our technology. It'll be safe, secure, to the best of our degree and intention, with especially powered by the Move language as our real brain, core nervous system, governance system of Supra blockchain. And we believe these use cases are only really possible in Supra.
Now, Super is rolling out our $100 million ecosystem fund. As we go to market, we've been in mainnet alpha since April of 2023. We're moving to mainnet beta. We're decentralizing our node network. This $100 million ecosystem fund is coming out of our Super tokens. We've been very careful not to oversell and tap into what we think is very important for the growth of not only our ecosystem and the Move language ecosystem, but Web3 at large. Our judges in this competition include folks from the Killer Whales TV show, Republic Crypto, Google Cloud, Hashing Capital, and more to be announced. So we do want folks to also keep an eye out for that. Think of new things that you could build that you can't build elsewhere, and come join the party. So that's about it. Thank you so much for your time.
So we're really grateful for this opportunity to host MoveCon. This is our 4th MoveCon. There's very interesting things in the horizon. I'm personally very bullish and confident that Move is going to make a significant impact in the world. Thank you for your time, and thank you for showing up. And we appreciate all of our speakers and panelists, true geniuses, some of the best researchers that have ever walked the planet, and appreciate all your time, Peter. Thank you so much.